everyone watching the stream, you can thank Jose for saving the stream. I was making some announcements, just a couple really quick ones for people who didn't catch it or are watching the recording. Bring a sharpened pencil to the exam. 298 now has a capacity of 80 instead of 40, so you should be able to get in. We'll expand a little bit more if we have to, if more people want to get in. And then both glossary pages for the exam are now available. These probably will not change unless I find an error in them. The front page, okay, pretty similar to the last year front page, but there are some absences and some additions which might be of interest to you. There is a second page, and I just had to put some more stuff on it and list some more stuff. But I also gave you some scratch and some planning space. Now remember, this scratch page right here is just for taking notes and ideas down. We will not accept this. We're not going to staple this, bolt this onto your exam. Okay? We're not going to allow you to do that. So you will want to be a little bit careful. A couple of these questions, involve some code. If you're not very compressed, then you might end up feeling the squeeze at the bottom of that box. Rewrite your code to give you more space, okay? Do not jam a bunch of stuff in the corner of the box, okay, and make me interpret it. I'm just going to cross it off and say I'm not reading this. If it is not legible or if it's a bit ambiguous, then you might be in some trouble, okay? So be careful. Plan out your code and where you're going to write, and you should be fine. Okay. So in just a moment, I want to talk about the quiz review, and then if you want, we can go over the previous exam if you have any questions about how that works. Going over that previous exam, I'm going to give you a good feel for the new one, okay? And then we can start the extra office hours and study hours early. Tonight, I'm going to print the exam. I'm going to print one copy of it and then do the exam myself, and if it all goes smoothly, I don't find any issues, we'll print 50 or 60 of them, however many I need with some extras. And that'll be it. If the machine breaks tonight, I've got Thursday to figure out what I'm going to do, and then Friday to deliver the exam. A reminder, those of you who, I think I've got 3 people who are going to be doing it in the Wolverine Soft office, alternate exam time, like an hour or 2 before the normal exam time. So if that describes you, just make sure you're there on time. I'm not going to be able to give you any time if you start late. Show up. And if you're nervous about that, send me an email tonight, okay? Or DM me. Okay, I want to tell you about a really cool game engine. This one is a big part of the University of Michigan game dev lore. Now, there was a time, legends tell of a period where EECS 494 was the only game dev course on campus. And it was also a game dev course that was much more focused on the technology side of things, kind of sort of getting an engine to run, and much less on the design side of things. This was an era where game engines weren't really available, okay? They weren't off the shelf, right? If you wanted a nice game engine, you had to build it yourself. You had to program it yourself. And that's a bit of a problem if you want to run a game dev course. Well, Mitchell Block, who was the GSI and then later one of the professors temporarily for EECS 494, wrote a game engine to support EECS 494. That game engine was known as the Zenilib engine. And I'm really sad because I went to look at the website and it's broken now. It's toast. So a lot of media might very well be gone, and it might no longer be possible to try and build this. He works at Amazon Game Studios now, so maybe if we reach out and ask nicely, he'll get everything uploaded to a new location. But you can see some of the media here in these screenshots. Zenny Maze 2008, right? This was a 3D engine, and it was C++ based. There was no scripting language, but there were some tools to help you out. Debugger, right? A little game right here, kind of a side-scrolling beat-em-up game. It looks to me like you've got a crowbar in your hand, but that's not the case. These are like scorpions you're trying to fight. And you're this little plug on wheels right here. Okay, you can see the graphics are kind of basic as far as 3D goes. This is partially the engine, but it's also partially that no one knew how to make their own engine and no one knew how to use Blender. In that era, Blender was hard to use, very hard to use, and other things were very expensive. It also had support for 2D as well. Probably my favorite game to come out of Zenilib, Coriolis Station. This was a game in which you basically manipulated gravity to kind of fling yourself around this space station and try and traverse it. It reminds me a little bit of V, if you've ever played that game, right? Simple aesthetics, really cool platforming challenges, all that good stuff. Question?
Okay, the name Zenilib makes me think. Is there any relation to ZeniMax, or is that just coincidence?
As far as I know, completely coincidental.
Okay.
Okay, so anyway, this is the engine that was that powered EECS-494, and students would get this engine, and they would have to learn how it works and build games with it in order to make 494 games. In this era, there was much less focus on game design because just getting games to build and run was much more challenging. You didn't get all the luxurious features that even our current engine provides. You did get 3D, but you didn't get a scripting language. The APIs were not as easy to use, and so that's how it went. As a result, the game was kind of a hybrid of 494 and 498 as it exists today. Okay, you learned a little bit about making game engines and new APIs and game engine tech, and you learned a little bit about game design, okay, and iteration. Now we have two separate courses that focus on each, and you can go much deeper, and the outcomes, in my opinion, are much better. But in general, gaming was not quite as advanced in the early 2000s as it is today, and certainly not as easy to get into, okay? Mitchell was a graduate student at the time. It was very popular on campus. It powered a bunch of Wolverine Soft games. We just recently recovered and rescued a bunch of, and backed up, archived, a bunch of Wolverine Soft games from this era, from 2000. And the club started in 1999. Crisis Wolverine is the famous game out of Wolverine Soft. You can play it, and if you get to the end, you get extra credit. And if you record your playthrough and send it to the initial devs, they love us for doing that. You'll get even more points. So anyway, yeah, all right. Last updated for Visual Studio 2012. That gets you a feel for how old this engine is now. Interestingly, the Visual Studio project is broken up into a bunch of kind of separate projects that all kind of output stuff. It looks like they're basically having you build STL for your local system. Okay, for instance, and they have a bunch of other stuff, Zenny Audio, Zenny Core, Zenny Graphics. Unfortunately, I have never been able to get this engine to build on any of my hardware. So I don't know if it's just kind of gone out of, if it's just gotten too old, or if it was always difficult to get it building. I don't know. It has a unique kind of stack-based approach to managing game state and menus. The idea being like, well, you're on the main menu, and you pop the gameplay scene onto the main menu, and then you pop the result screen state onto the gameplay, which is on top of the main menu, and then you want to play the game again, so you pop the result screen off, and you're back in the gameplay state. And kind of weird, in my opinion, but kind of unique. I think of most games and progression through a game not as a stack, but as a kind of cyclic graph. So, right, it's more of a loop. You're jumping from node to node instead of something that's stack-based. But, it's kind of interesting. This used to be a slide deck, but it has also broken. A lot of the materials stored for this engine were stored on UVM's web server, which they recently killed. They moved to new web hosting, and it all died. Hopefully it's backed up somewhere so that history isn't lost completely. I think I have the repo cloned or something on my home computer, so maybe I'll mirror it or something. I don't know.
I think like for Zenilib,
Yeah.
think it's still, you can just look up Zenilib.
Oh, can I? Oh, great. Let's try it. Basalt Zenilib, yeah. How old is it? 12 years ago. Oh, awesome. Great, cool. Okay, I'm just going to copy that. Okay. And let's do GitHub. There we go. So you can experiment with it and try and get it working if you want to, and hopefully you have better luck than I did. Very nostalgic, a very cool part of Wolverine game dev history. Not super relevant or impactful today, but definitely impactful back in the day. Okay? All right, good. Any questions, any comments? I'm very nostalgic for that time period. I still remember big starry-eyed Austin on campus, right? Walking around like, you made this engine? Wow, Mitchell Blocks, you're so cool. And yeah, all those early developers, they blazed a big trail for us. So grateful to them. Yes.
I just sent in the memes channel. There's a Wolverine Soft Museum website that has a lot of Zenny.
Really? Oh, fantastic. Oh, yeah.
Zenny is on there.
You put that together, right?
Oh, Ravi made it.
Ravi did it. Oh, that's fantastic.
I uploaded Zenny though. That's why I remembered it.
Yes, great. That's fantastic. That's fantastic. Let me quickly open this up real quick. I'm just going to take this off real quick, just in case I show like an NDA channel or something like that. Okay, nope, we're good. Cool, Wolverine Soft to GitHub. Now, this is safe until GitHub goes under. Yeah. So then we're back in trouble again. Yeah, so a lot of Wolverine Soft games. I don't see any of my games backed up.
So disc from 2008 maybe?
Yeah, I didn't arrive on campus to 2011. So
I think the cutoff for this was like anything that's stored like on hard drive.
Yeah. Cool.
From like 99.
Yeah. Yeah, this is really cool. I'm going to add this right here. Featuring.
If you know where we can find like stuff from like 2008 to like 2020, that would be nice.
Yeah. I have video footage and some backups of random things from that era because I ran it from 2011 to 2015, right in the middle. But yeah, we used to have a really cool website. It kind of got bulldozed and everyone lost the data. Yeah, all it takes is one kind of mediocre officer corps to really mess things up. But thankfully, all of our Wolverine Soft offices are amazing lately. And yeah, good stuff. Okay, excellent. All right, any questions about any of this? Okay, so I want to quickly go through some of the questions that were a bit more difficult on the quiz from Monday. Okay, and here are a bunch of them that we kind of identified as being very low score. So you can see about 25% of our students messed this one up. And this isn't even a question. Okay. Basically, data-oriented programming is often, it is a question. No, that's the full thing. It describes succinctly as, this is a phrase we brought up, I'm pretty sure, in lecture, and I think it even might come up in the assignment spec for homework 9. But the basic idea here is that we no longer want to think of our containers as being just simple arrays of objects that are stored contiguously one after another. Because remember, these objects are going to have data members inside of them, making them big, making them chunky. That makes it slow to load them and do operations on them. If we want only the X and Y positions, but the object has a name, it has all this other stuff, right? We have to load the big object just to get the X and Y. No, that stinks, okay? What we do instead is we think of objects of arrays. Often this looks like basically you've got a struct, and that one struct is just a global container for these gigantic arrays that you have. Thus, when you want to do computation, you can go and only access the arrays that are relevant to your particular computation. So that allows you to, for instance, not load in the big string that represents the character's name. Okay, you don't care about the character's name. It's not going to enter cache. You'll be much more efficient if you don't load the entire object. So, yeah, this right here, the number 2 choice, I like how the only other one that confused people was the object-oriented one. So, thinking of arrays of objects is object-oriented programming. The opposite of what the correct answer is. Data-oriented programming is objects of arrays. Okay? So nothing too crazy there. Here's one. This is right. This is around a quarter. Again, about a quarter of students messed this one up. You design a simple simulation in which a box falls. Moments later, the box receives a force to send it flying. To clarify, the force is being applied via a Lua, basically, or possibly being another object being launched into it. Okay, it's moving. A force is applied somehow. Okay. The box flies further depending on whether or not you put a collider on it. And this is one of the things that the assignment spec, I think, brings up when it comes to, for instance, phantom fixtures. This is a little quirk of how Box2D works. When you add fixtures onto an object, I believe the fixture is what defines the density of that object. And density, if you've got a bunch of dense objects, right, fixtures on your object, that increases mass. And that causes you to move less when you get that force or more. And that's how it goes, yeah.
That made me fail a test case because I had the thought, maybe I shouldn't double up the density and all the physics properties of an object if I have both a collider and a trigger. I had that check to make sure, okay, let's not double up if I do. Then I went to test case 9.0. Oh, wait, why am I getting it wrong? Oh, I have to double up the properties if both exist.
Yeah.
I would, at least, I don't think I would probably make a comment on that homework class.
Yeah.
For that one test case, make a note that AutoGrader assumes, regardless of whether or not one or both are there, you will apply physics properties to both.
Yeah. Can you send me a DM? Because what I'll probably do is I'll probably edit the hint for that test case. Say, hey, by the way, this is one of the first test cases where you need to make sure you're doing fixtures this certain way.
Yeah.
Okay. Yeah. Thank you. I really appreciate it. Yeah, that's how a course gets smoother over time. It's like, what do we teach you in 494? You need to deliver knowledge at the exact moment it's useful. Otherwise, people will miss it or forget about it, or it comes too late and it's not helpful. And so, yeah, it's good. Okay. Anyway, yeah, so each additional fixture kind of changes your overall density and thus your mass. Okay, the next one, I'm a little bit surprised this was as tough as it was because I'm pretty sure we said this in lecture as well. I think the assignment spec also says this. It describes exactly this image and what it is. Let's check that out, actually. 498. Let's go to homework 9. Yeah. Okay. Yeah, so slow versus fast. Runtime efficiency, blah, 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 blah. Yeah. Data-oriented design optimizes usage of the cache by placing operation-relevant objects close together in memory, spatial locality, right image, and keeping them small. By contrast, in object-oriented programming, the classes that we load in a cache often contain data we don't need, causing additional cache misses, slowing down our computation. Left. The white space represents irrelevant members of a bird class that must be loaded in a cache just to use the position stuff. Right? Yeah, so it's right there in the assignment spec. I think we mentioned that in lecture as well when this imagery came up. And so it shouldn't have been too tough to say, yeah, it's basically just it's basically just irrelevant computation data. Alignment is kind of interesting. So alignment, I think, is a bit of a different topic. But the fact that these patterns are cascading kind of makes it look like this jigsaw pattern, like it's not aligned properly, it's not beautiful. So I wonder if that's why a lot of students chose that one. I'm guessing that's probably why. But the topic of object misalignment is not something that I think ever comes up in this course. Yeah.
I mean, I could see how it could be interpreted that way.
Yeah.
It's not what it's supposed to be, but like you can see how like if the bird was just a horribly
mangled
class, then there would be a whole bunch of space lost in the cache from just like if the bird 0 element is like aligned to 8 bytes and the vector 3 was aligned to like 32 bytes, you can see how that space would be lost. But
it's definitely not what it's referring to, but I can see it. Maybe I delete that question for next year, or maybe I don't know. Okay, this one was bizarre. A lot of students messed up this one. Data-oriented programming is sometimes said to have strong similarities to what kind of database? Relational database is the one that we talked about in class, in lecture. This makes me wonder if maybe we're not watching the lectures quite at the right cadence, or maybe a lot of students haven't gotten to the lecture yet. They're watching it from home or via recording and just didn't see us talk about that. NoSQL database. Does anyone who chose NoSQL want to tell me like why? You can do it in private, or you don't have to do it at all. Go for it.
I didn't choose NoSQL, but my guess is because it has SQL in it. So maybe you think of. I mean, it's like kind of like I don't know. It's kind of like what you think of when you think of a database. I don't know.
So they're like, oh, yeah, that thing I learned in 484. What was that called again? SQL. Oh, that's the one.
Yeah.
Click. Right? No, NoSQL is. It's kind of a unique name for a database type because it's defining itself by what it's not, right? As opposed to what it is. NoSQL, if I recall, NoSQL is usually extremely high performance, extremely scalable databases that ditch a bunch of relational properties to go for more of a key value store approach to data. And for certain things, they're really great, and for any sort of reporting or complexity or relationships between different objects, they're a nightmare. Yeah, tough time. Okay, here's another question. This one is actually a little bit tricky, but I think this is also one that came up during lecture. This is the question of, do we get performance benefits, notable ones, significant ones, by simply converting our objects into arrays? We have a big chunky object, take all of those properties the object has, bust them out into arrays, and then change nothing else. Do you get performance improvements? The answer, as far as I can tell in my experiments, is almost always no. So right here, if you look closely, we have the situation where we have an actor object, a struct that has an integer representing HP, it has attack, it has defense for HP, and in this main function, we perform a computation that uses HP, uses attack, uses defense, okay? So that struct is going to get loaded into cache, and we run the computation. So can we make that faster? Well, this example tries to break that out into a bunch of arrays. But here's the thing. We're still using every single property in that struct. So we're going to have to load all the attack data, all the HP data, all the defense data in anyway. Okay? We're not really saving anything. If this actor right here had a string name, what is the name of the character? What's the name of the actor? Then we could do this computation down here without loading the name in. And that would probably provide, at large enough scale, pretty noticeable performance benefit because strings are big. Those things are massive. Okay? And so, please keep in mind that data-oriented programming is not just, ooh, we just busted it out into an array and now everything's great. If that were the case, does that sound like something the compiler could probably do for us automatically? Right? And if the compiler can do that stuff for us automatically, we're probably not studying data-oriented. We just study it in the compiler's course. We don't write data-oriented code ourselves. But anyway, so yeah, please keep that in mind. I think, did everyone mess this up? Ooh, oh my goodness. All right. Nearly half the class messed this one up. A lot of the class chose, yes, the data-oriented approach is going to be noticeably more cache-friendly in this case. That is not the case. So, okay, that's how it goes. All right, but it's a tough question, right? And that's definitely something that you should think about and make sure that you do some experiments, time some code, okay? Create some dummy examples that could help you on the exam. No joke. Okay, we got another question. 25% of us messed this up. Data-oriented programming encourages logic to be written in bundles with the following performant properties, okay? With data-oriented programming, you do get iteration over small contiguous objects. The objects tend to be smaller. They tend to be contiguous, okay? You put them in containers that put them right next to each other. You tend to not have branching happen as much. There are ways to write data-oriented code to kind of eliminate branches, which can allow you to do interesting SIMD things, allow the processor to run hyper-fast, stuff like that. And we talked in the lecture about how easy it often is to parallelize and get multiple threads involved when you've broken things out into data-oriented design. These things, these three incorrect answers, are properties of object-oriented programming, not data-oriented programming, okay? The fact that data members are kind of packed in, at least logically, with your, or syntactically, with your data on an object is very nice and convenient. It makes things easy to read. It's great for humans. It's good to optimize dev time, not good to optimize runtime. Okay, so got to be a bit careful about that. Iteration over large scattered objects. Object-oriented programming tends to create large objects. And if you are using new, you are throwing things all over the heap. Okay, so neither of these is typically what you see with data-oriented programming. Okay, we try and get away from these things with data-oriented programming. And use of convenient variant types. This is just an answer I put on here that doesn't really make any sense because I felt like I needed another option. All right. We haven't really talked too much about variants. Lua-ref is a variant type, but that doesn't really have much to do with data-oriented programming. Okay, so just a strange option there, so you don't choose it. And that's it. Anyone else have any questions they want to talk about? Okay, so does anyone have any questions? Would it be useful for me to go over the previous exam? Did you kind of do that in discussion? No? Okay, I feel like I might be stealing some discussion material from my IAs, but that's simply the hierarchy of power here, okay? But I'll also say that discussion, I think, is ending. This is, you're done with discussion. There's no more discussion sections, in part because we don't know what all y'all are going to be working on after this exam, okay? You could be doing anything, and so we can't really create a lecture that's going to appeal to everyone. We can create a lecture, but discussions are more homework and assignment based. We're going to be talking very soon about CMake. I think we're probably going to try and hit that topic on Monday or maybe a little bit later. We'll see what happens. Okay, so let's go ahead and did I lose my, where'd my thing go? I think I lost my exam. I had it pulled up. Well, I got to be careful not to, oh no. I have to go into my Google Drive. The stream is going. All right, I'm going to end the stream so I can grab the exam I don't want to show you. And I'm going to relaunch the stream. I'm going to have to upload 2 parts now. Great. Okay. Everyone, I'll see you in a sec.